question you gave to us. The formula
Yeah.
for power is P equals to W over T, which is work done
Yes.
over time.
Yes.
Then if we are multiplying 1,000 by 10,000 as given from the question, we'll have a million, about 10 million.
Yeah.
Then the 100, which is 100 seconds, are we supposed to
Yes.
divide or multiply?
Multiply.
Okay, let's do it like this. Let's do it like this. The formula is P equals W over T, right?
Yes, sir.
So let's make E, let's make W the subject of formula first. So making W subject of
Okay.
formula from P equals W over T, you'll be having W equals P times T,
Times T.
right?
Yes, sir.
So from P times T, we can now see that our P is 10 million times the time 100 seconds. So it will give us 1 billion. I don't know whether it's clear now.
Good, now, thank Thank you.
Okay, you're welcome.
Thank you, sir. It's cleared now.
Yeah, thank you. You're welcome. So now let's go. I said something here. Yeah.
Hello, sir. And
Yeah, I'm
this
listening.
second or rather third paragraph, for example, let's
Mhm.
consider the conversion from kilowatt hour to joules. This kilowatt
Yeah.
hour, there is no coefficient in that case. So do we assume that is 1 kilowatt per hour?
Yes. Yes. Yes.
Okay.
So with that being said, I said if you're writing on your note, just write one at one corner of your note. Say to convert from 1 kilowatt hour as 1 kWh, converting it to joules per second. Sorry, is it joules I'll talk about? Converting it to joules per second, yes. Or to watt second. No, let's make it watt second so it'll be simpler. Converting from 1 kWh to WS is going to be equal to that particular thing times 1,000 times 3,600, like what we have at this top here. So you are converting from any kilowatt hour to watt second, you would have to multiply by these two things. But if you are converting from only kilowatt to watt, you multiply by only 1,000. You multiply by if you are changing from kilowatt hour to watt second, you multiply by 1,000 and by 3,600. But if you are changing from just kilowatt to watt, you multiply by just 1,000. So I just hope that's clear now.
Excuse sir. From a kilowatt hour to watts per second, we multiply by only 1,000.
No.
Is that what you said?
And I'm not saying what. No, I'm not saying watts per second. Not watts per second. Watt second.
Okay, watt second. All right.
So it is 1,000 times 3,600. So it's only when you're not seeing hour that you multiply by only 1,000. When you see hour, you multiply by 1,000 and 3,600.
Okay, so I have to add 3,006 there.
Yes, when you have kilowatt an hour.
Kilowatt hour. I said
when you're changing from kilowatt hour
to watt second, I multiply by 1,000 and 1,000 times 3 times 3,600. Yes. Okay, the second one you said. Yes. The second point.
When you just have kilowatts, when you have just kilowatts, you just multiply by 1,000. Simple. To convert from kilowatts to watts, that one is basic math. From kilowatts to watts, just by multiplying by 1,000. So in order for us not to dwell so much here, let's move on to the next slide. So now we have conservation of energy law. So for those of us that were present in I think chemistry class, last chemistry class, we were talking about, I don't know whether it was chemistry or physics class, we were talking about conservation of momentum. And we're talking about even in chemistry class, we talked about the
So I
conservation of
have something to
mass.
I have something to complain about. All those all those lectures, we we
Yeah,
couldn't get the screenshots because of if we continue to draw you back, we might not finish. So we didn't get all the screenshot, you know. So our
yeah,
coordinator supposed to post those things. Now we are in 6th week. In fact, the
yeah.
ones I learned when you were teaching, I've forgotten them because I don't have comprehensive screenshot, and he has not posted anything for us to go through and make our note. Maybe you drop it for us
Okay.
in the group.
Apologies for that. I'm
The
actually the person
central
supposed to
group.
be the one. Yeah, I'm the one that's
Pardon?
supposed to be posting it. Yeah, I'm supposed to be the one that is posting it, but most of the times I do forget most of the times. Like the things on my hands are usually much, and for that reason, sometimes it will skip my mind. Sometimes it skips
Please,
my mind, or
can we
sometimes
have
even
your number so that when you forget, we remind you?
just drop your question. Just on the group, just say, please, could you help us with physics slide? Once you say it like that on the group, someone will respond to you and they would at least take action towards that. You get
On the central
But
teacher.
on the central
can we have your number?
yeah. uh, for
It's necessary.
privacy
It's
reasons
necessary
for
we have your
now.
number.
For privacy reasons for now, just let's just
Okay.
if
Okay.
there will
No
be need,
problem.
if there will be need, if there will be need, there will be no problem. So if there will be
Like
need,
it's
you
for
see, you will get.
personal reasons. It's for just
I know.
personal reasons. Maybe for like private tutor, yeah? Like private or just
This
that
girl
person.
is a
Maybe I'm
go.
teaching her.
Don't worry, don't worry, don't worry. We are here
This
for you.
girl
We are here for
is
all of you. So let's continue with lessons for today. Let's continue so we'll not spend much time here. So we have conservation of energy law. Conservation of energy law. So we have the popular one that says energy cannot be created nor destroyed, but can only be transformed from one form to another. So this is the general law of conservation of energy. And it applies the same way to conservation of mass. In case of mass, they will say matter can neither be created nor destroyed, but can be transformed from one form to another. So for energy, this is the formula. Not really a formula, this is the law of conservation of energy. Another way it is being stated that the total mechanical energy remains constant in a closed system. So these two are known as the conservation of energy, the law of conservation of energy. So that energy can neither be created nor destroyed, but can be transformed from one form to another. So this conversion from one form to another, we'll be seeing it just shortly. We'll see what it means by energy being converted from one form to another. The second one says that total mechanical energy remains constant in a closed system. For people that will be dealing with thermodynamics, probably as they move forward in maybe their studies in university, you would know what it means by a closed system. But for just for knowledge sake, a closed system is a system um, that does not allow the flow of energy out of the system, and it does not also allow it does not allow the flow of energy out of the system, but it might allow the flow of what am I saying? It does not allow the flow of energy and it does not allow the flow of matter. That's what a closed system is. That's what a closed system is. It does not allow the flow of energy and also it does not allow the flow of matter. So that's what a closed system is. It is closed. An open system is one that matter can come in. Matter can come in. And also energy can go out and come in. So for a closed system, yeah.
So you just use one, either energy or matter, to define it, or you put both.
No, in case of conservation of energy, you're talking about energy. But when you talk about conservation of mass, that's when you talk about matter. When you talk about mass, conservation of mass, you talk about matter. But when you talk about conservation of energy, you talk about energy. So they are not the same. They're not the same thing, but they are looking alike, the two laws. So closed system, I was saying something about closed system. I think I was making a mistake. A closed system is one that energy can be exchanged with the surrounding, but matter cannot be exchanged with the surrounding, because we have closed system, open system, and isolated system. But that's not for this level. That's under thermodynamics, and but it's not for this level. So according to the law of conservation of energy, according to the law, they say total mechanical energy remains constant in a closed system. So let's move on to the total mechanical energy, because we mentioned something about it in this conservation of this law. So the total mechanical energy is calculated as kinetic energy plus potential energy. The total kinetic energy plus total kinetic energy is the sum of both of them is what gives us the total mechanical energy, or TME. TME. So if they ask you to find the total mechanical energy, it's always equal to kinetic energy plus potential energy. So whatever it gives you is going to be the total mechanical energy. And according to the law of conservation of mass, it remains constant for closed system. For open system, it might behave different. It might not be constant, but for closed system, it's always going to be constant. So now we have here, I said in free fall, potential energy decreases while kinetic energy increases. What does this mean? It means that if you are dropping an object, just dropping an object and allowing it to fall by itself through the air, as it is falling, the potential energy keeps on decreasing while the kinetic energy keeps on increasing. And the reason why this is happening is because when something is falling, acceleration due to gravity is acting on it, and the velocity of that thing is also increasing. So since acceleration is happening, the velocity will also be increasing. And as velocity is increasing, it means that the kinetic energy will be increasing as well, because kinetic energy, the formula for kinetic energy is half mv squared. So kinetic energy is half mg squared. So as just the main idea is, when an object is undergoing free fall, potential energy decreases while kinetic energy increases when an object is undergoing free fall. So this one is just for knowledge on one side of your mind, and for case of objective, you could see it in your objective question where they'll say, what happens to potential energy? Sorry, what happens to potential energy when an object is dropped from a particular height? They're just trying to say the same thing, but they're restructuring the same thing. So the potential energy when an object is dropped freely from a particular height would decrease, while the kinetic energy would increase. So that's for that. While the mechanical energy, total mechanical energy is the sum of kinetic energy and potential energy. So at the highest point, when we're comparing this free fall. So free fall is dropping an object from a particular height and allowing it to fall down without anything interfering with it. That phenomenon is called free fall, so that it's not like as if it's a new something. If you have your key and maybe you climb upstairs, carry your key up and drop it down, not throwing it or just leaving it to fall direct. So that's called free fall. So at that point where you are holding your key, that is the highest point that the key got to. The potential energy is at the maximum value. But as the thing starts dropping, the potential energy starts reducing, and while the kinetic energy starts increasing. And at that point, when the potential energy is at its maximum, the kinetic energy is at its minimum. The kinetic energy is at zero. Because at that point, it has not started moving. When it is on your hand, when the key is still on your hand, the potential energy is at the maximum value it can ever be. While the kinetic energy is zero, because the key is still on your hand, it has not started moving. But the moment you leave the key to fall, the potential energy starts dropping immediately, and the kinetic energy starts increasing. So that's the idea that we're trying to pass out here. We're trying to pass this idea here, that potential energy and kinetic energy, the sum of potential energy and kinetic energy will give us the total mechanical energy. And during free fall, as the object is undergoing free fall, the potential energy keeps reducing while the kinetic energy keeps increasing. But at the time that the object is at its highest point, the potential energy is maximum while the kinetic energy is zero. I don't know whether you guys can hear me.
Yes, sir.
Okay. So with that being said, let's move on to the next slide. So examples of energy conservation. So when you hear energy conservation, it means that energy is being saved, that energy is not lost. According to the law of conservation of energy, they're just trying to say that energy is neither lost nor gained. So examples of systems that show energy conservation is a pendulum swing. I don't know how many of you have seen a single pendulum bulb that will continuously keep
Yeah.
dangling. It continuously be dangling under normal circumstances. If there is
So please, I've
no
not seen your
air,
next slide.
can
I'm
you see it
seeing it
now?
now. Thank you. Sorry.
Okay.
Yes.
So when you have a system of a pendulum, the what they call it, if there is no external force acting on it, like maybe air or wind interference, and you pull that pendulum to an angle and leave it to fall, like just leave it alone, it keep on swinging continuously, keep on swinging continuously, and forever and ever that thing might continue swinging if there was no air resistance. It continuously be swinging like that forever if there were no air resistance. So, and this phenomenon is trying to explain that, it's just trying to explain the theory, the law of conservation of energy, that when all things are being equal, when there are no external force acting on a particular system, the system would always conserve its energy. Even if its potential energy is reducing, it will get to a point where it would reach its maximum again, come back again to a minimum, come back again to the maximum. It will continuously be within that range. It will never become destroyed. The energy will never completely be wiped out if nothing is hindering that system. So the reason why that pendulum bulb I was talking about, if you pull it backwards, it's supposed to keep on dangling forever. But because of our air resistance and gravity, they would always be, before you know it, would be, with time, it start reducing its speed, and before you know it would end up becoming static. But it will take a longer time because on a normal, it wants to keep on swinging like that. But due to air resistance and gravity, it would not be able to have its way completely. So that's an example of a system that tries to explain the law of conservation of energy. Another system is roller coaster. Roller coaster, all those kind of things that they usually see in amusement park, all those kind of stuff that are in amusement park that they'll keep on moving like in a circular movement, like continuous movement. So this system, they are constructed with the theory, with that law, with the principle of conservation of energy. They might continuously be rolling unless someone stops the system. They might continuously be rolling, continuously be rolling because the energy is always conserved in those type of systems. And also free falling objects. If there were no gravity, something will continuously be floating or falling or forever, just continuously be falling. But so long as there is gravity and there's an object that is resisting it, it would reduce, it will keep on reducing. So these systems are systems that can help you try explaining energy conservation. So next we have real life applications. We are seeing real life applications of power, energy, and work. So the first example I have here is hydroelectric power generation. Hydroelectric power generation, which harnesses the flow of energy through water. That's what we see in dam, all these Kanji dam, all these dams that would stop an amount of flowing water and allow it just allow a single tiny opening. You can see it now.
Yes, you can see.
No, I'm just seeing that energy conservation.
So we have these
When
examples as the hello, is someone saying something? Okay, we have these examples as the examples for
Hi.
applications. Okay, seems like someone's network is backward. So we have these examples as the examples for the applications of energy, work, and power. Hydroelectric generation, power generation systems.
I can't see that. I
Mm,
can't see that example. So I can't see that slide. Sorry. Let me try
real
to
life
join and see if it's
applications.
gonna show.
Okay, real life application. That's what is on the screen now. So we have engineering systems. They make use of work energy and power. Electric vehicles. They make use of work energy and power. Household appliances. They make use of work energy and power. Industrial manufacturing. They make use of work energy and power. Renewable energy technologies like solar panels, and their likes, they make use of work, energy, and power. So these are just applications of work, energy, and power. So these are some experiments that can help to explain it. Is this we might not already have this experiment because this one is supposed to be an experiment session, but for reasons we might not be able to carry out this experiment. So if you we have said demonstrate energy transformation in simple system. These are the experiments that I'm supposed to carry out, but for the sake of the fact that it is a virtual class, we will not be able to carry out experiments. So normally these are the experiments that are supposed to carry out on standard condition, understanding the principle of conservation of mechanical energy in closed system. Gain
Hello,
hands
sir.
on
Please,
lab
I didn't get screenshots of the one before this
application.
experimental review. Please, let me
Okay,
screenshot
see
it.
it here.
Please.
So this is we are already getting towards the end of the class. As I said today, it's not really going to be long. The next slide is experiments, and I was saying that the experiments will not necessarily be doing any experiment because we are on a virtual class. Maybe later on we'll find a way. So the final portion of this lesson now is talking about energy conversion. Energy conversion. So energy conversion is talking about the way energy is being changed from one form to another. If you can remember when I was mentioning the law of conservation of energy, we said energy can neither be created nor destroyed, but can be converted from or can be transformed from one form to another. So it can be transformed from chemical to mechanical. It can be transformed from electrical to mechanical. It can transform from gravitational to kinetic. Transform from different forms. Different forms. So now, what I will give as assignment now, I will give it as assignment because this is the end of this lesson. What I'll be giving as assignment now is I'll go back to that first slide where I listed the types of energy, and on the group between today and tomorrow evening, I would
Lost.
need
Oh,
someone
I'm
to
lost. Please, I'm lost.
okay. Where we were after these applications, we talked about the different applications of
The
work,
one
energy, and
before
power.
this experiment, this one, please give me time to screenshot it. You know it's too long.
Okay, it's supposed to be a screenshot. It's not supposed to take time.
It's network issue now. Like this long one, I usually screenshot 3 times to get the whole.
Okay. So as I was saying, I said I will be giving an assignment, and that assignment would be I would go back to the places where we had forms of energy. Then we'll take each of those forms of energy and transform them from one form to another form of energy. You look for systems that transforms from one of the forms of energy to another. So I'll give an example of what I mean. So that's where we are here. This is where we are. We're under conversion, energy conversion. And from here, I said potential
Are you,
energy to kinetic energy.
are
Can you
you
see my
going to
slide
post
now?
the assignment? Yes. Are you going to post the assignment in the group?
Okay, is it the question for the assignment or just the assignment?
The questions for the assignment and the example you said you are going to give.
Okay, I'll try to see how I can use to I'll post it here. I'll post it this evening, right? This evening. So the
All right, no problem. Thank
assignment,
you.
I'll give you the description of what the assignment is like now. The assignment is just trying to talk about how energy is being converted from one form to
Okay.
another. So now we had from this from our lesson at the beginning, we had these points. We had these 7 types of energy. So now what I will need you to do is if you take kinetic energy, you say okay, kinetic energy to potential energy. Then you now write EG. That's for example, you now mention a system that converts from kinetic energy to potential energy. The next one you go potential energy now. You take and you now say okay, potential energy, maybe potential energy to electrical energy. You try to find a system that converts potential energy to kinetic to electrical energy. The third one, chemical energy to another energy. You look for another system that maybe you do it randomly. You don't need to copy anybody. So just pick any two forms of energy and tell me a system that converts from
Sir,
this
please,
one of
would you
energy to
like to
another
post
energy.
it on the group? 'Cause,
Yes, I'll post it on the group.
rushing, I'm not getting this thing.
Okay, the main thing is just
Yes,
to
he
get
said he's
what I'm
going to
trying.
post it on the group.
Explain.
I'll, I'll post it on the group, and I'm just trying to give an explanation of what is expected or what is required. So these same 7 lists
Okay,
will be
sir.
what I
Okay.
would give. These same 7 lists is what I'll be giving. These 7 lists is what I'll be giving. And what you just need to do is just, for number one, pair number one with any other number and look for a system that converts from that one to another one. Let's assume I choose number 1 and number 6. I'll look for a system that converts from kinetic energy to thermal energy, and I'll write it. Maybe I'll say an electric fan converts from kinetic energy to thermal energy. I'm just giving an instance. An electric fan is an example. Maybe I say from sound energy to thermal energy. I'll now say a freezer, maybe an electric fridge converts from sound energy to thermal energy. Just that kind of stuff. That I just need 7 of this energy. Choose another extra energy and see how they convert, and mention a system that probably tells how they convert from one form to another. I hope it is clear.
Yes.
Yes, sir.
Okay.
Yes, sir,
So
it's clear.
Sir,
okay, I think
please,
that
the
will be the
slide.
end of.
No, the slide,
As
Biko.
which of the slides?
Huh? Wait, let me
Which
screenshot
of the slides?
the the second to the last, second and third to the last one.
Don't worry. Just right now, just on the group. If you wait after this call, if you wait for 5 minutes and you don't see this slide, post a message that I've not seen the slide for physics. Just post it, because I'll send it immediately after this class. But if you don't see it after 5 minutes of this class being over, just say, please, I've not seen the slide for physics, and it will be posted.
No, it's not all of them. I just need that one. The one you will post for us is the old ones. Week 1 to week 5. We don't have them. But this one, I have them. It's just the last two. Second,
This one,
I've screenshot this one.
this
Sir,
one.
please post all of them, sir, for people that don't have it.
My
This
intention is to
one.
post all.
This
My intention
one.
is to post all of them. My intention is to post all of them from week 1 to week this. But there is a plan to put it inside. Well, let's see.
Okay,
I'll
first
see whether I'll
now,
post them on the group. I'll see whether I
I
can post them
better.
on the group. But
I've
today's one,
seen the
I'll
plan
post.
that they are planning.
I'll post today's one on the group.
Sir,
I'll
please
post today's one on the group.
let
No
us have
problem. Please do that.
Okay,
our notes
alongside
to
with the
read
assignment.
before they
Alongside with
are
the
along.
assignment. So
Thank you.
with that being said, that will be all for this lesson. So we talked about work, and we talked about the formula for work. We talked about energy and different forms of energy that exist. We also talked about power, and we also compared energy and power. And we stated the law of conservation of energy. And we also saw the calculation for total mechanical energy. So that was actually what we had for this whole lesson for today. So with all this being said, we've come to the end of today's lesson, and I'll say goodbye to everyone. Thank you all for attending, and have a good night
Sir,
rest.
please look at the number.
I don't go yet
You said,
to the other one. Is that experiment? Post that one now, please.
okay, see the
Not
experiment here.
Zion,
This
sir,
experiment. Please allow me to
Uh,
take it too.
okay, I'm listening. Someone wants to say something.
the number.
Okay, Oh God. What's
Are you calling
okay?
it?
No, I'm not. I'm not yet calling it, but I would know if I'm to drop my number on the group by the end of today. You get?
Okay, sir, no problem.
If I'm to drop it, I would let you know. If not, then I would still let you guys know. You will see it, a message from the supervisor on the group in regards this.
Okay,
And the
sir.
reason for that is for privacy reasons. So if there will be a
Yeah,
need, there will be,
it's
if there
not
will be a
for.
need,
No problem.
yeah,
It's
I
just
know
for
you
those
said it's
that
for.
need the
She said it's
private.
for.
Yeah, private
Yeah,
reasons,
I get that.
personal reasons.
I get that part. I get that part too. I get that part too. So I'll relate it with the supervisor and
Yes, sir.
any
Thank
conclusion that it is, I'll pass it on to you guys. Then you would get the number, depending on how the
you. Okay, thank
conversation
you very
goes.
much, sir.
Anything that happens, we'll give you the feedback. And if there's any alternative, yeah, you're welcome.
Okay, sir.
So good night to everyone and bye.